own papers, those self-citations are also counted while you are calculating CH index, sorry, H index. But this author says that you can calculate CH index by excluding all the self-citations. So when you are arranging all your papers based on number of citations, you have to minus the self-citations received for individual papers. And whatever H index you get after excluding self-citations, that is called CH index. What about CH square index? Same way, how you calculated H square index, you will calculate CH square index. Only difference is that you are going to exclude all the self-citations. So CH and CH square talks about excluding self-citation count from the total citations received by you for each and every one of your papers. Good, yes. Then comes G index. In the year 2006, Leo Egge introduced another index called G index. He claims that this index is better than H index, and normally G index is more for individuals than H index. And his formula, his definition goes this way. G index means the largest number such that the top G articles receive together at least G square citations. Here two things are important. One is we are going to find out the cumulative citations, and secondly we are going to square the rank which we have assigned to each and every paper. And here we are going to compare not the rank and citations, but we are going to compare the cumulative citations and the squared rank of the individuals. That's the difference between H index and G index. You take this particular case, same 10 papers, arranged according to number of citations. Now I am finding out the cumulative score. 70, first paper. First two papers, 70 plus 12, 82. First three papers taken together, 70 plus 12 plus 6, 88. So this way, I find out the cumulative citations of all the papers. And secondly, I square the rank of each and every paper. 1 into 1, 1, 2 into 2, 4, 3 into 3, 9, this way. Now, I am going to compare these two things, the cumulative citation score and the squared rank. Either both should be equal or citation should be more than the rank, and rank, fine. That way. So here, let me see this. Is there any point where this cumulative citation and the squared rank are equal? They're not equal. But here you can see here, in this particular case, citations are more, rank is less. Only this case, citation is more, rank is less. And so we conclude that his G index is 10. That means that his 10 papers all together, have received at least 10 square, that is 100 citations. So his G index is 10. So this we can calculate G index for the authors. Good. Sir, where can I find all these indices? For example, go to Web of Science. Web of Science explicitly gives you what is the H index of each and every individual author. The same way, go to Scopus. In the Scopus, there's an option for author search. You search for any author and they provide H index for each and every author. You can find out in Scopus. Fine, good. Then comes I-10 index, the next popular research matrix. A matrix which was introduced long before in 2011 by Google in its product called the Google Scholar. It's very simple. For example, you are having 10 papers. Out of 10 papers, 5 papers have got at least 10 citations each. If it is so, your I-10 index will be 5. If your I-10 index is 1, it means that only one of your papers has received 10 or more than 10 citations. Good, fine. For example, this is my profile. You can see here, my H index is 6 and I-10 index is 3. Fine. And what about Dr. I. Rama of Department of Chemistry, Sitalashmi Ramaswamy College? Madam's H index is 4 and I-10 index is 2. And what about Kanjana ma'am, the same college? H index is 3, I-10 index is 3. What about Dr. D. Rajalakshmi ma'am, the same college? H index 5, I-10 index 4. It means that out of all the papers, madam's 4 papers have received at least 10 or more than 10 citations. Good. This you can find out. So these are the normally used research metrics: H index, G index, and I-10 index. Apart from these indices, there are many other indices proposed by various researchers over a period of time, because these researchers have found out some issues or some problems in the H index or G index and such other indexes. So there are many more indices of M quotient. The same author who introduced H index in 2005, having known the deficiency of H index, this gentleman introduced another index called M quotient, same research paper. As I told you, see, there is an institution, you got different kinds of professors whose career length is already different. There is a professor with 40 years of experience. There is a professor with 20 years of experience. There is a professor with only 10 years of experience. See, how can you compare the relative effectiveness of the research impact of all these 3 individuals, those who are having 3 different career length? So that is not good, no? How can you give weightage to the same H index to all these people having different career length? Having understood this particular problem, the Hirsch has introduced a new thing called M quotient. The formula goes this way: the researcher's H index divided by the number of years since his or her first publication. Very simple. For example, first author, he is having H index of 8, but he has been publishing papers only since 4 years. Okay. And there's another author whose H index is 24, but he has been publishing for the last 8 years. Now we are going to calculate M quotient. How to calculate? H index divided by the number of publication years of an individual. 8 divided by 4, 2 is the M quotient. 24 divided by 8, 3 is the M quotient. Now here, authors are having different years of experience: 4 years, 8 years, 12 years, 18 years. But here you can see M quotient, if you check, no, only this particular author is very, very, very effective compared to author 1, author 3, and author 4. And author 4, though he is having 18 years of experience, and his M quotient is comparatively lesser than the third author. So M quotient helps you to understand when the authors are having different career length, how can you find out the author who is effective with the help of 2 things: their H index and number of years for long they have been publishing papers. This is M quotient. Good. Then comes M index, a index which was proposed by Boneman in 2008. It is very simple. M index says, see, for example, you find out the H index of a particular author, okay, and whatever H index he has received, see, from the H index above, whatever papers are there, those papers are called H core papers, and whatever papers are lying below that number of citation, they are called H tail citations. You take only H core papers, arrange all the H core papers in the descending order. You find out the median. Median means the middlemost number, the number that divides a number series into 2 ops. That is what the M index is. I'll just give an example. Here, author A, author B, they have published 20 research papers. You can see here, this author published 20 research papers. First paper has got 47 citation, second paper 42, last paper 11 citations. And his H index is 13. What about the second author? He also published 20 papers and his H index is also 13. Let me ask a plain question. Just to go through the number of citation received by first author, number of citation received by second author. Who do you think that both are equal? I don't think both are equal, because author A comparatively has got more number of citations for his paper than the second author. But the H index of both authors are only 13. So now, using this M index, I am going to differentiate though their H index is one and the same, I am going to show you who is better than whom. Okay, good. How to calculate? Very simple. I have arranged all the 20 papers, and up to H index, they are called H core. Remaining papers which we are not considering are called as H tail. Okay, you take only up to 13. 13 is H index. Now, you find out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The middlemost value 17 is the M index of first author, and 14 is the M index of second author. So M index tells you the citations received by you only in the H code. You arrange all the citations, find out the median number that speaks about your M index. This is the other index. Good. Now, there is another index, a beautiful index called the E index. I told you when your H index is 3, even if you are having only 9 citations, that is more than sufficient. 3 for first paper, 3 for second paper, 3 for third paper. But you are having 100 citations. That means you are having 91 excess citations. This particular E index talks about how using the excess citations, we can find out the authors who are better when they are having almost equal H index. Fine. So this particular index is proposed by Zhang long before. Good. So you can see here, I give an example here. See, there is a scientist called A. He has received total citations of 3568. Total citations received by him. His H index is 51. That means in order to obtain 51 as his H index, he should have minimum obtained 2601 citations. 51 H index means each one of the 51 papers has received at least 51 citations. So 51 into 51 is equal to 2601. See, if he has received 2601 citations, he can very well get a H index of 51. But he has earned 3568 citations. So what is the excess number of citations he received? It's very simple. 3568 minus 260 is equal to 967. So 967 is nothing but the excess citations received by individuals over and above the H index. Now, if you find out the square root of this excess citations, 31.09, that is called his E index. Okay. For example, I'll show you here. There are 3 scientists here. First scientist, second scientist, third scientist. Almost, they're all having almost equal H index, 51, 51, 50. But if you're calculating E index based on the excess citations received by them, you can understand who is better. See, their E index is 31 for first author, 54 for second author, 114 for third author. It means that when H index is almost same, when we have to give weightage to excess citations, normally author C shines as the best author. Fine. You can use E index when you want to give consideration to the excess citations received by the individual concerned. Okay, fine. Then comes Scopus author metrics. In the year 2023, Scopus introduced a new metric called author position metrics. For example, you might have published some 20, 30 papers. Maybe you might have published single author papers, only you are the author. In some papers, you are the first author. In some papers, you are the last author. In some papers, you are the co-author. Co-author, I mean, neither first author nor last author. In between, you may be second author, third author, fourth, not the last author. So they are the co-authors. So based on your position in the research paper, Scopus started giving metrics and citations. Okay, that's a kind of new thing from Scopus. Okay, I'll just show you here. This one particular author called Jennifer, his Scopus page, I think it's very clear now. See, first author, see, he has published only 3 papers in which only he is the author, solo performance. He has got 3 documents. His average citation is 1333. Then he has appeared as the last author in 104 documents, his average citations. And he is the co-author in 70 papers. And he is the first author in 3 papers. And he is the only author in 10 papers. So, based on the author's position in the research paper, Scopus gives you the number of papers and average citations received by you for that particular position. Okay, even this can be used by you, but unfortunately, when I was trying to find out what is my author position matrix, I was not able to see because I have not subscribed to Scopus. See, only when you are subscribed to Scopus, you will be able to see this author position matrix. Good. Yes. Next one, individual Hutch index, which was proposed by a scientist called Battista. A beautiful concept. See, for example, what they say is that, see, when you are publishing research paper, you are publishing papers as a second author, third author, with the two authors, with three authors, four authors. So when you're calculating citations and Hutch index, don't you think that you are taking the credit for the entire research paper? See, paper is written by four authors. All the four authors take a credit of one each. But actually, it is not to be done. It is not to be done so. You have to divide the citations. You have to divide the citation impact among all the authors. That is what the concept proposed by Battista called individual Hutch index. How to calculate? Very, very simple. Standard Hutch index divided by average number of authors in the articles contributing to Hutch index. Very simple. I give an example. This is an author called X. His Hutch index is a 10. Okay. And in all these 10 papers, you go on the total number of authors. First paper 3, second paper 2, 5, third paper 3, 8. This way, you go and add all the number of authors in all the 10 papers. How many authors are there? There are 28 authors found in 10 papers. Okay. You have to find out the average number of authors. 28 authors divided by 10 papers. So every paper has got an average of 2.8 authors. Now they say your Hutch index divided by this average number of authors, 2.8, is equal to 3.57. That means that as far as you as an individual is concerned, you are having the eligibility to get only 3.57 as your individual Hutch index. Hutch index of 10 is meant for all authors, not only your contribution. That is a viewpoint of Battista when we formulated this individual Hutch index. Okay, good. Then comes another two interesting indices. One is called Hutch A index, which was proposed by Fazin. And there is another index, very popular index called normalized individual Hutch index. So you might have heard about a beautiful software called POP, publish or produce. The person who was behind the introduction of this particular software is Kurzing. So Kurzing introduced a software, a new index called normalized individual Hutch index. Let us see both these indices. See, Kurzing says how to calculate normalized individual Hutch index. Very simple. You have to normalize the number of citations for each paper by dividing the number of citations by the number of authors. Very simple. You are going to normalize how? Number of citation divided by number of authors. After calculating the normalized count of citations, you go on to calculate a Hutch index. I'll give an example here. For example, here, this Hutch index we calculated for a particular author. Now, I am going to find out the normalized citation count. How do I calculate? Citation divided by number of authors. 66 divided by 3, 22. 54 divided by 2, 27. 49 divided by 1, 49. So this way, I calculate normalized citation count. After calculating normalized citation count for each and every one of the research papers, I am arranging all these papers based on the normalized citation count. Fine. Yes. Okay. The papers are arranged according to the normalized citation count. Then you go and calculate Hutch index for this particular author. That Hutch index is called as normalized individual Hutch index. Okay. This is another version of Hutch index. Then comes Hutch A index. In Hutch A index, what we are going to do is that, very simple. When you are going to rank the citations, you have to rank them by number of citations